Hey everybody, Mrmathblog here. This lesson is Properties of Parallelograms. And don't forget, all your lessons can be found at Mrmathblog.com. Let's take a look at that real quick. I have it up right here. Here's Mrmathblog.com. I've rearranged these, trying to put them in order. So integrated math looks like it's going to be right here. So when I start teaching next year integrated math 2, I'll have a link for it right about here. But if we click integrated math 1, here's your whole textbook on there, and it's going to go way down here somewhere. Okay, so down in, I think this is module 24.1. Okay, all right, so here's our essential question is what can we conclude about the sides, the angles, and the diagonals of a parallelogram? Okay, so here's some definitions. You've heard of this one before. Quadrilateral is a polygon that has four sides. So any four-sided figure, there's a square right there, or a rectangle, or that's called a parallelogram. That's what we're talking about today. Or any four-sided figure is called a quadrilateral. Now, a special quadrilateral is a parallelogram. A parallelogram is a quad that has, oops, there's supposed to be a T right there, that has two pairs of parallel sides. So like this one here, this pair is parallel and the top and bottom are parallel. So there's two pairs of parallel sides right there. Okay, so like this guy right there, or this guy right there, or this is a parallelogram and this is a parallelogram right there because there's two pairs of parallel sides. All right, so properties of a parallelogram. Okay, well, opposite sides of a parallelogram are parallel. Well, that's what we just talked about right there. And notice both pairs of opposite sides are parallel, and they're marked by the red arrows. So these one red arrows on these sides mean that these two sides are parallel, and the two red arrows means it's parallel with this one that has two red arrows. So that's how we mark parallel sides, is with arrows right there. Okay, the next one is both pairs of opposite sides of a parallelogram are congruent. Okay, so here the top and bottom are marked by one dash right here, and the left and right are marked by two dashes. So that signifies that these two sides are equal and these two sides are equal. So both pairs of opposite sides are congruent. Okay, next one is both pairs of opposite angles are congruent. Okay, so here we have the congruent angles shown by the arc mark. So this has one arc, it's congruent to this one with one arc. This one has two arcs, so that means it's congruent to this one with two arcs. These opposite angles are congruent and these opposite angles are congruent. Both pairs of opposite angles are congruent. Okay, the diagonals, this one's the one that a lot of students forget. The diagonals of a parallelogram bisect each other. Well, bisect means cut in half. So here's a parallelogram. Here's a couple of diagonals right here. Okay, here's one diagonal that's bisected or cut in half. Can you see now that this side equals this side right here? Similarly, this side equals this side right here. So we'll mark those with two dashes. So the diagonals are bisected. So if it's a parallelogram, those diagonals cut each other in half. Okay, and then consecutive angles of a parallelogram are supplementary. So here's a parallelogram A, B, C, D, and they always go in order right here. So you can either go clockwise or counterclockwise, okay? But it will never do this. It will never go A, B over here, C, D. It'll never skip. It always goes in order. A, B, C, D, okay? It might go counterclockwise, go A, B, C, D. It doesn't matter. So what this means is consecutive angles are next to each other. They're not the opposite angles. So like A and B, these guys are supplementary. So are B and C. So are C and D. So are A and D, okay, or D and A. So supplementary means they add up to 180. Okay, now notice, you guys, if there's an equal sign on this, then it has a little M in front of the angle measure. If that M wasn't there, then we'd use the congruent symbols. But whenever dealing with numbers or measurement, you guys, then we always have the M, and there will be an equal sign right there. Okay, just semantics that the books carry on with. Okay, so here we're going to prove that opposite sides are congruent. Opposite sides of a parallelogram are congruent. So here we're given that this is a parallelogram. We are going to prove that AB is congruent to CD. Now notice, these guys have the segment on top, so it has the congruency symbol right here. Okay, if there was no segment on top, it would have an equal sign. All right, now we're going to prove that AD, segment AD, is congruent to segment CB right there. Okay, all right, let's just slide that up and make some room. And so they give us a box and give us some information right here. Now notice, you guys, the given is always your first statement, this guy right here, and always your last statement is this prove statement right here. It goes right here. The reason is not prove right there. Even though the reason right here is given, don't write prove right there. A lot of students want to do that. There is some reason right there. And always after congruent triangles, always, always, always CPCTC. So I already know that's what that's going to be right there. All right, so we're going to get some triangles congruent right here. Okay, so ABCD is a parallelogram. Let's say that's given. Okay. And then draw DB. Okay, so DB goes from here to here. So let's go ahead and draw a segment right there. And we're going to get now, because any 2 points determines one line. So you say like through any 2 points there's exactly one line, or any 2 points gives you a line, something like that. Okay, now we're going to prove that this top triangle is congruent to this bottom triangle, and that's what's going to go right here, the congruent triangles. Then we can say by CPCTC that this side equals this side and this side equals this side. Once you get this triangle up here congruent to this triangle, we are on our way. Okay, so now we're right here. AB is parallel to DC. Why is AB parallel to DC? And why is AD parallel to BC? Well, that's because it's a parallelogram. So definition of a parallelogram right there. Okay. Now notice I marked them with the arrows symbol to show that they're parallel right there. Okay. Now let's look at these angles right here. Angle ADB. Here's ADB. Start at A to D to B. So I'm going to put a little arc mark right there. It's congruent to angle CBD. So CBD, so that's going to be this arc right here. So this angle is congruent to this angle right here, and similarly this angle right here is going to be congruent to this angle right here. So let's mark that real quick, you guys. Okay, now why are those angles congruent right there? Well, because we have parallel lines cut by this transversal. Do you remember what kind of angles these are called? The double marked angles right there? They're called alternate interior angles. And so are these. With these parallel lines, the lefty and the righty over here, cut by this transversal, they form also congruent alternate interior angles. So you can say congruent alternate interior angles, or your book says alternate interior angles theorem, something like that. All right. Why? Now, look, we got two angles in one triangle congruent to two angles in another triangle, and then we're going to say they both share a side DB, so DB is congruent to DB by the reflexive property. Now notice I marked it right there. All right, can you see angle, side, angle? Angle, side, angle. Okay, so now that's where this comes from right here. The triangles are congruent. So it doesn't matter which order you put the first triangle in, but whatever order this is, we got to be in the corresponding order to here. So let's go look at it. A, B, D. Okay, we went from no arc to two arcs to one arc. So we got to go from no arc, C, to two arcs, D, to the one arc, B. So CDB right there. So that's what's going to go right there. And then finally, by CPCTC, since the top triangle is congruent to the bottom triangle, then this side equals this side, and this side equals this side, because congruent triangles have corresponding congruent parts. CPCTC. Okay, this actually stands for corresponding parts of congruent triangles are congruent. All right. That was fun, wasn't it, you guys? Let's try another. All right, so we're going to complete the flow proof, okay? These are kind of weird, I think, but they're cool. That the diagonals of a parallelogram bisect each other. So given it's a parallelogram, we're going to prove that this diagonal, this piece is equal to this piece, and we're also going to prove that this piece right here equals this piece right here. Okay, all right, so let's move that up to get some room, and there's a flow chart proof. Okay, remember, this goes in the top box right here, and this, where does this go? This goes right down there. So let's go ahead and do that right there. Okay, so it says right here, that's given, and it says CPCTC. That's what those are right there. Okay, now it says definition of a parallelogram right here. Okay, Now, it doesn't matter which pair of triangles you get congruent. I'm going to get the top triangle and the bottom triangle congruent. But I could, for the same reasoning, get the lefty congruent to the righty. But we're going to focus on the top and the bottom. So I'm going to say, because it's a parallelogram right here, this top piece, AB, is parallel to this bottom piece right here. Okay, so that's what's going to go right there. Okay, notice I put arrows up there, and we're going to do that good old alternate interior angles theorem again, because we got parallel lines cut by a couple of transversals right there. All right, and then it says opposite sides of a parallelogram are congruent. Okay, remember, we're doing the top and the bottom triangle, so I'm just going to say AB is congruent to DC. Now, if you wanted to, it's not needed in this, but you can say this side is congruent to this side too. All right, so now let's go do the alternate interior angles theorem. So I'm going to say this angle right here is congruent to this angle right here, and then we're going to mark it. Okay, so this angle, I can't say angle A because there's three angles up there, this angle, and the whole angle. So I got to say angle BA, I don't know if I said C or BAE, but anyways, this angle right here is going to be congruent to this angle. Let's see what I said right there, ABE. Okay, so ABE, that's this little dude right here, is congruent to angle CDE. So there's one arc and there's one arc, and then we said the other one is this one is congruent to this one. That's what this says right here. Okay, now look, you guys, we got an angle, a side, an angle congruent to an angle, a side, an angle. It doesn't matter which order you put the first letters, but you got to be corresponding to the second one. So here I said ABD. Let's look at, I'm sorry, ABE. So I went from A to B to E. So I went from 2 arcs to 1 arc to no arc. So I got to go from 2 to 1 to no. So CDE. Okay? And then finally CPCTC. Now I know you're having fun. That stuff is fun, right? All right, so here we go, you guys. So we got a parallelogram. Find the measure of each. Okay, so it says, so here's the markings right here. Here's our parallelogram. Remember, opposite sides are congruent and opposite angles are congruent. So let's get AD, okay? AD is this bottom one right here. So I'm going to say 7x equals 5x plus 19, okay? Because opposite sides of a parallelogram are congruent. Once we find x, remember it says find AD, so I got to put whatever x is, got to multiply it by 7, okay? So I'm going to subtract 5x from both sides and get 7x minus 5x is 2x equals 19, and 2 goes into 19, 9.5. Now, x is not the answer, you guys. We got to plug that into 7x. So we're going to go 7 times 9.5, and AD is 66.5, whatever the units are right there. All right, to get angle B, you guys, we're going to set this angle equal to this angle right here. Opposite angles of a parallelogram are congruent, okay? All right, so here I'm going to subtract 6y from both sides and get 8y minus 6y is 2y, and I'll add 17 to both sides, so 17 plus 5 is 22. All right, y is 11. Okay, remember, we got to find angle B, so we're going to plug in 11 right here. So 6 times 11 plus 5, and then 6 times 11 is 66. 66 plus 5 is 71 degrees, okay? So this is 71 right here, so what's this right here? That last theorem we had was that consecutive angles are supplementary, which means 180. Okay, so we're going to go ahead and plug in 71 and subtract that from 180, and we get 109. Okay, let's try another one here. So here's another parallelogram. Find these measures. Okay, so QR is over here, right here. So remember, these opposite sides are congruent. So we're going to go ahead and find Z first. So the opposite sides are congruent. So when let's see, I'll subtract 2z from 3z, and I'll go plus 4, so we get z equals 8. Okay, and then remember, we got to find out what is QR, so 3 times z minus 4, or 3 times 8 minus 4, and so we get 20 on that, okay? And then to find PR, you guys, remember the diagonals bisect each other, so this piece equals this piece right here, okay? So when we do that, we plug that in and we solve for x, we get x equals 5. All right, now, so if we plugged in 5 right here, 5 plus 9 is 14, or if we plugged in 5 right here, 4 times 5 is 20, 20 minus 6 is also 14. Okay, so, but they want to know what's the whole length right there, so PR is going to be twice PT. So it's going to be twice that 14 or 28 on that. All right, you guys, if you are in my class, you guys go ahead and try that. Take care.